Welcome. So what I want to go is go through the standard form of our sine and cosine function. And what we're going to do is once I go through the kind of the standard form, I'm going to write them up there. Then I'm just going to kind of explain what exactly each little form is going to do. And even though I have a specific video on each one, I'll just kind of give you a quick little run around again on how to use the standard form to help you graph and understand the transformations of the graph. So let's look at the standard form of the sine graph. So the standard form of sine graph can be written as y equals d plus a sine of bx minus c. And the cosine, let's do cosine down below. Cosine graph can be written as y equals a cosine of bx minus c plus d. Now you might say, well, why are these different? Why'd you add d in front and then here you added d behind? The reason why I want to add a on both sides is a lot of times we like to write the d in front, and we do that because therefore we don't want you to get it confused with what the function is going to be. However, a lot of times this also confuses students because then they get this mixed up with what actually is the sine of d, and that's going to affect your graph. So I wrote it in both different forms. Really whichever way you should understand both ways. All I'm doing is adding d either after the function or adding d before the function. So I just kind of wrote it in two different forms. So let's just kind of go through the alphabet, and I'll go through quickly explain what actually each term is going to be used, and then how it affects our graph. So let's first look at the a. So when we're dealing with the a is going to have a couple of options that it's going to do. First thing, the absolute value of a is going to equal our amplitude. Right? So that's going to be how much our graph is. That's going to be half the distance from the maximum or the minimum of the graph. A also is going to be a reflection of the x or y axis. Or I'm sorry, just if it's negative is going to be the x-axis. So therefore, if we have opposite of a, that means if we have a negative value, therefore that means the graph is going to reflect the x-axis. Okay, we'll actually talk about not reflecting the y. That's just going to reflect the x-axis. Okay, so now let's go over to our b. Now our b is going to affect has a couple things. Our b is going to affect our period, and it's going to affect our phase shift. It most commonly affects our period because when finding the period of sine and cosine, we take 2 pi divided by b, and that's going to equal our period. Okay? The other statement is also when you have a negative b, what that means is now you're going to reflect the y-axis. All right? Now, b is going to have an effect on the phase shift, but what I'm going to do is I'm going to use that in the definition of c. So c, and that's going to kind of be with c and b, c is going to be dealing with our phase shift. Now, the reason how we know what the phase shift is going to be, it's actually going to be b and c because they're going to affect the phase shift together. Now, if b had a value of 1, then c would be the only factor that would affect your phase shift. But a lot of times we have a factor of b and c, so therefore we need to combine them together. So when looking at the phase shift, you could say bx minus c equals 0 is going to help you determine what is going to be the phase shift of the graph. And that's going to be how the graph is going to get shift left or right. And again, if b is 1, then your formula would just be x minus c will determine the phase shift. However, since sometimes we have b and c, I want to put them in the same category. And then last but not least, we have d. And d is going to affect the vertical translation. So we can just say that whatever the value of v is going to be equal to the vertical translation. And what that means is that's just going to tell us how much the graph is going to shift up or the graph is going to shift down. And that's why sometimes it can be confusing because here you can say, oh, if I had a positive d, that means I'd shift it up. If it was subtract d, you'd go down. But here a lot of times, sometimes we forget that since there's no plus in front that, oh yeah, it's positive. Or if it's negative, you're going to be shifting down. So there you go, ladies and gentlemen. That's the standard form of sine and cosine. Thanks.